Here we are, week 17, day 2 Bellwork. How does the thermometer work? Continuing to explore that concept. A typical outdoor thermometer consists of a thin glass tube filled with a colored liquid. Like most substances, the liquid inside a thermometer expands when it is heated and contracts when it is cooled. The height of the column of liquid, which tells you the temperature, is read from a scale along the side of the thermometer. Knowing that temperature is actually a measure of the kinetic energy of molecules makes it easier to understand how a thermometer works. As molecules of air move, they hit the walls of a thermometer with kinetic energy. Each collision between an air molecule and the wall of the thermometer results in a transfer of thermal energy from the air to molecules in the thermometer. This causes the molecules in the liquid to gain kinetic energy and move farther apart, expanding the liquid. When the liquid inside the thermometer reaches the same temperature as the air, thermal energy stops flowing and the liquid stops expanding. Now you can read the temperature. So we have two diagrams here that are kind of showing you how those molecules will expand, the liquid inside, the air outside, and how that kind of will dictate the temperature and the reading on the thermometer. So you see over here, the air outside, 20 degrees Celsius, about 68 degrees Fahrenheit. Those air molecules, even though that's not a cold temperature, it's colder compared to the other diagram, so those molecules are not going to be moving around as fast or freely compared to 40 degrees Celsius, which is 104 degrees Fahrenheit. So the air outside, those molecules are moving very freely and at a rapid pace. So part A, if the temperature is 80 degrees Fahrenheit outside, does the air transfer more or less thermal energy to a thermometer than if it is 60 degrees Fahrenheit? Well, we should know that 80 degrees Fahrenheit, warmer than 60 degrees Fahrenheit, so therefore it should transfer more thermal energy to the thermometer. So you would say it's going to transfer more thermal energy because a higher temperature means the air molecules have more kinetic energy, which means they transfer more thermal energy. There you go. And then B, explain why, when you have a fever, you have to keep a thermometer in your mouth for a certain length of time in order to read your correct temperature. Well, the reason behind that is how, in this first paragraph, it talks about giving time for the molecules of the thermometer to reach the same temperature. So you have to wait for those molecules of the thermometer to reach the same temperature as the molecules in your mouth. That's why we have to leave the thermometer in there for a certain length of time. There you have it, guys. There's your Bellwork, week 17, day 2. Hope you guys have a good day.